Hello students, in this part of my video we will be learning about organization of data that earlier we saw that the data is organized in two ways, in simple frequency distribution and in group frequency distribution. In this part of the video we will be learning that how to organize the data into a group frequency distribution. So we saw the final picture of a group to frequency distribution, but now we will be work on how to construct the group frequency distribution. Alright, so to organize raw data into group frequency distribution, following are the steps that needs to be followed. Now for step 1, the first step is to determine that how many number of classes the data should be organized. Alright, so we need to know that in how many classes we need to organize a data. Now there is no as such rule for determining the number of classes, so it mostly depends on our own judgment, or it depends on the size of the data, or we can say that it depends on how many classes you want to take or want to organize the data into. Now the general number of classes lie between 5 and 15. Okay, so it can be more than that as well, but this is somewhere like 5 to 15. In general classes we divide the data into 5 to 15 classes, and as I said, there is no rule for determining the number of classes, so it depends usually on one's judgment that in how many classes we need to, or they need to distribute their data into. Step 2, the next thing that we need to determine is the height, or we say the width of class interval. Alright, now the width of class interval, the height of class interval is calculated as h equals to range divided by the number of classes. So range means the maximum observation given, the minimum observations given, and number of classes is represented by k. Now height and width doesn't means that we are talking about one class range. Alright, we are talking about the height, that is the height between the first class and the second class, the height between second and third and fourth. So this is basically height. Alright, not talking about the range of the class, that is that starting point and ending point of a class. We are talking about height or width, which means we are talking difference between two classes. Okay, if we are dividing a set of data into classes, so if first point is given for any one class, then what will be the second point of the next class? Alright, the first point of the next class. So height is basically the difference of two classes, 2 points. Now it can be lower points or higher points, but it's actually the difference of two classes. So height is, or width is, calculated as maximum observation minus minimum observation divided by the number of classes. Okay, let's say if the height comes, if we just calculate the height and it comes in some fraction value, so always class is taken as the next whole number. Alright, so if let's say 5.3 is given, so we will take height as 6. There's an example given. Let range of any data is, let's say it's given as 32, and we wanted to divide that data into 6 classes. Alright, then height is range divided by number of classes. 32 divided by 6 is 5.33. Alright, so the next whole number is 6, so we will take height as 6. Step 3, the next step is to decide the starting point of the first class. Since we have wanted to organize our data into classes, alright, so we first need to decide what will be the starting point of my first class. Now sometimes it is taken as the least or the minimum value of the given set, or you can take values which are less than the minimum value of the data which is given to us. Alright, let's say that if the data starts from 15, the raw observations that you get, the minimum observation you came across is 15. So you can start constructing your classes with that point, that is 15, or you can start constructing your class with a point less than 15 but not greater. Alright, because if 15 is included in that data, we will gonna miss that value if we don't include it in if you just start a data with a higher number of a minimum observation. So the rule out here is that either you start with the minimum point of the data, alright, or you can take a point less than the minimum observation. Now step 4. In next step, we start adding height to the lower limit of first class and determine the lower limit of second class. This process is repeated and depends on the nature of data, or we can say it depends on how many classes we have divided the data. We will be keep on adding height until we reach the number of classes that we have set. Okay, step 5. Now the step 5 is that you need to determine the upper class limit of the classes. Now upper class limit is what? That let's say we have started the data from 15 and we are ending that class at what point? So 15 is the lower limit of the class, and the point that we are going to select, okay, or the point that should be the upper limit, the next point that we say the range will be the upper limit of the class. So if let's say we have discrete data. Now discrete data means that the data that is given in whole number form. Alright, so there are two types of data, discrete and continuous. One data is discrete, in which all the observations are calculated in whole number form, or you can say that all observations are given in whole number form. And the second type of data is continuous data, where decimal point data is given. What decimal point data means is, let's say we are talking about height. So height can be 5, 5.1, 5.2. So this is all basically continuous data. Alright, or weight, if you're talking about someone is 71.2, 71.4. So this is a continuous type of data. The discrete data that I'm talking about are, let's say we deal with the whole numbers. Alright, we deal with the marks of the students that are in whole number form, 35, 45, 55, 31, 32. No in between marks. Either you score 31 or it rounded off towards the next value. If someone is scoring 31.5, it is rounded off towards the next value. So it's like it works like that. So we have a data which is in whole number form, which is called discrete data, or we have a data which is in continuous form, which is decimal points. Alright, whenever discrete data is given, there should be a gap. Alright, whether discrete given or continuous data are given, there should be a gap between two classes. Alright, because let's say if there is no gap, so we won't be able to construct the exact data, or if some point lies between two classes, it will be confusing for us to decide in which class we need to put that frequency in. So there should always, when you yourself are constructing the data, there should always be a gap between the starting of one class and the ending, between the ending of the one class and starting of the other class. Alright, okay, now gap of 1 unit is taken when data is in whole numbers, and when data is given in decimal form, a gap of 0.1 is taken. Alright, so we will be working on it, that how it exactly happens. What is gap between two classes? That is, a gap of 1 unit means that, let's say if the class is starting from 15 and it's ending at 20, so the next class should start at 21. Alright, and let's say if a class is starting at, if first class is starting at 1.5 and it's ending at 2.4. Alright, so the next class should start from 2.5. It should not be like the class is ending and the other class, the end point of one class should not be the same of the starting point of the other class. It should be, there should be a gap between two classes. Alright, Step 6. So once the data is organized, the next step is to find the frequency of all the relative classes. Now counting of frequencies can be done by using telemarks. So these are basically the telemarks. You can use them to calculate the frequencies, or you can, if you're comfortable doing it directly, it is up to you. You can use the telemarks, or if you don't want to use the telemarks, that is completely fine. Alright, so this is an example. Following data shows the marks of 20 students formed into an array of ascending order. Now the data was given is already in ascending order. They've shown that this particular data is in ascending form, and it's the marks of 20 students. Alright, starting from 35, that is the minimum point in this whole observation is 35. The maximum point is 54. Alright, minimum observation in this set of data is 35. Maximum observation in this set of data is 54. So the above data gives the following information. Number 1, the minimum marks are 35 and the maximum marks are 54. Now we need to calculate the range, because we need to divide this into classes. For that we need height, we need the number of classes as well. So the difference of maximum and minimum point is 19. So if you just calculate the range, 54 minus 35 will give you 19. This is basically how you calculate range. Then there's a heavy concentration of marks between 40 and 52. If you just go back towards the data, you can see 40 and 52, there are more marks between this range as compared to 35 to 39 and 52 to 54. Okay, a majority of students secure 43 marks. That depends on the frequency, because it was already arranged in array, so we can directly look at it and give this remark that majority of the marks were 43. Okay, now as a general rule, it says that the classes should lie between 5 to 50, and or it depends on the size of the data. So here I'm taking number of classes as 5. So I want to divide this data into 5 classes. So first of all, I need to calculate the height. So height means range divided by classes. Range I have calculated, that was maximum observation 54 minus minimum observation, that was 35. So 54 minus 35 was 19. Since I wanted to divide this data into 5 classes, so I have written 5 out here. After calculating this value, I came across 3.8. Rounding up to the next decimal place, next point, that is 4. So my height out here is 4. So these are two important steps. You need to calculate the height. You need to decide, or we say that you should calculate the height first, and then you should decide that how many classes you want to sort your data into. Alright, the minimum observation was 35. The next step is that we need to decide that what should be the minimum point, okay, or the minimum observation to start a classes. Since it was 35 in this data, so I've taken 35 and I have taken it as the lower limit of my first class. See, this is a table that I have made. This represents K, means number of classes, class intervals, telemarks, and frequency. Since I wanted to divide my data into 5 classes, I've written class 1, class 2, class 3, class 4, and class 5. Alright, and I've taken my minimum point as 35. Okay, now what I have done out here is that I've started, this is basically the lower limit. Alright, now I need to find out lower limit of next class, so I'll add height in it. So 35 plus 4, height was 4, so 35 plus 4 is 39. Okay, so this is how I calculate my height, or height is calculated. And since we are dealing with uniform data, so it should be equal number of heights, so all the heights should be equal throughout the classes. even data, right? So it says now we'll start adding height or width in the lower limit of first class to obtain lower limit of second class. The first point of my class was 35. Now I will be moving on towards my second class, deciding the lower limit of my second class. So what I will do is that I'll add 4 or height value in this point, in my initial starting point, to get the lower limit or the first point of the second class. Now repeating this procedure, I've repeated this procedure. See, the initial starting point that I have started from was 35. I've started adding height, that is 4, and I got lower limit of my second class. Then I start adding 4 and got lower limit of my third class, then for fourth class and fifth class. So 35, 39, 43, 47 and 51. Okay, now to obtain the upper limit of the classes. So as I said, that since the data was given to us in discrete form, in whole number form, there should be a gap between two classes. All right, and if the data was discrete, since it was, so what we are going to do is we're going to leave a gap of 1 unit between two classes. Now this means that, see, my first point was 35 and I start adding height. All right, now this point is also needed, that is the upper limit. Now this is called the lower limit, this is called the upper limit. All right, so since this, the next class is starting from 39, so 1 minus 39 is 38. So this is basically the upper limit of my first class. As you can see, the next class was starting at 43, so the previous class should end at 42. 1 unit minus from the lower limit of the next class. 47 minus 1 gives you 46, which is the upper limit of my third class. Then 51 minus 50 minus 1 gives you 50. So this is the upper limit of my fourth class. Now if you talk about this number, see, height, if you just look at the height from with the lower limit, or if you look at the height from the upper limit point of view, both are same. 39 minus 35 is 4 and 42 minus 38 is also 4. So if you wanted to know the value for this place, so it's simply like just add 4 in this number and you'll get the height, you'll get the low upper limit of the last class, because we have already wanted to divide the data into 5 classes. So this is my final limit, and since you can see that all my data is arranged in such a way that minimum observation to maximum observations both are present in this compact form. Now it is very important that these two values should be in your data. Let's suppose that you have organized your data into 5 classes and the maximum observation is appearing in the next class, or somehow what happened is that after you decide all these ranges, the maximum observation is not in the classes that you have set. So for that you need to repeat the process, increase another class and then start your process all over. That is, you need to calculate height once again. So it is important that the minimum limit of the class and the minimum observation and the maximum observation should be in the classes, should be organized, or should be in the classes you have decided. If not, then you have to increase the classes and then you have to recalculate height, and then you'll start this process all over. All right, so this is how you calculate your class intervals. See, I'm repeating this thing. What we have done out here, that I have initially taken my lower class, my initial point for first class, that was 35, and I've start adding height. All right, so height is 35 plus 4, which gives me 39. Now these values are all lower limits, these values are all upper limits. Then I start adding 4 in this value, that is lower limit of second class. I got 43. Then 43 plus 4 gives me 47. 47 plus 4 gives me 51. Now why I'm not moving further, it is because I have already decided to set my number of classes, or to organize my classes into 5, organize my data into 5 classes. So this is the point that I need to stop. Alright, then to find out the upper limit for all classes, what you're going to do is you're going to look at the next class lower limit minus 1, and you get the point for upper class. Like 39 is the starting point of the second class, then the first class should end at 38. 43 was the starting point of my third class, then second class should end at 42. 1 point minus the lower limit of third class. Alright, same as 47 was the lower limit or the starting point of my fourth class, so 47 minus 1 is 46. Alright, so 46 is the point, is the upper limit or the final limit of my third class. Then 51 was the point where my fifth class was starting, so 51 minus 1 is 50, so 50 is the point for my fourth class. And then if I need to find out this value, since the height is same throughout the lower limits, throughout the upper limits, you can check 42 minus 38 4, 46 minus 42 4, 50 minus 46 4, 54 minus 50 is 4. So if you need to find out value for your upper class, just add 4 in this point and you'll get the upper limit of your final class as well. Alright, see, these all values marked in green are my lower limits, and the values that are marked in black are my upper limit class. Okay, so now we will start counting frequencies for each classes. Now this was my data that was given to me, and I wanted to find out frequency for all respective classes. For class 1, the range is given starting from 35 to 38. Now we'll go back to my data and see how many observations are lying between 35 to 38. Now as you can see that I've already made a column of telemarks, that is these marks. Okay, so 35 and 36, 39 is not appearing in this class range, so there are only two set of values which are appearing in class 1. So I've made 2 telemarks, and corresponding to this 2 telemarks I have written down the frequency as 2. Then 39 to 40, the next limit was 39 to 40. Now start counting how many 39 to 42. Now I'll start counting how many observation lies between 39 to 42. So 1 2 3 4 5 6. Okay, so if I am using telemarks 1 2 3 4, see, I've cancelled this just to just to understand that these are 5 values. So for 5, what I'm going to do is that it's easy to read when it's done like that if you have more set of values, you can do it like this 1 2 3 4 and just cross it, so that you can say that this is basically representing 5 marks and this is 6. So 1 2 3 4 5 and 6. So frequency for this class is 6. Then for 43 to 46, now we'll start calculating how many values are, or we'll start counting how many values are there for the class 43 to 46, how many values lie in this range. So 1 2 3 4 5 6 and 7. There are in total 7 values, 1 2 3 4 5 6 7. Now it is up to you actually that if you wanted to use telemarks or not. This column is completely on choice. If you wanted to calculate by using telemarks, you can do that, or you can just directly count it, that how many values are there, and directly write down the frequency. So this is completely up to you. Now 47 to 50, now there are no values from 47 to 50, so no telemarks, the frequency is 0. Alright, 51 to 54, so 1 2 3 4 5, there are 5 values, 1 2 3 4 5, so 5 telemarks, and the frequency is 5. So if you just add all these values, 2 plus 6 plus 7 plus 5, so it'll give you 20. And our observations were also 20, so it is important that the summation, the sum of frequency should be equal to the number of observations given. Alright, if there are 20 observations, the sum of frequency should also be 20, because frequency is basically the number of count of that value which is appearing in the data. So if you are just reducing any frequency, or if some calculation error or counting error occurs, usually counting error occurs, and you missed any frequency, so this will eventually change, this value will change. Alright, this value will change, so this is not right. The whole working will go wrong, because frequencies are important. You cannot subtract any frequencies on your own. You cannot add any number in the given range of your own. It usually happens due to counting error. So you have to be very focused when you're doing we are counting frequencies, because out here I've taken a data which is small in number, easy to handle. 20 observations are easy to handle, but it's not always the case. Sometimes you get observations in hundreds, in thousands. So hundreds of observations, or observations above like 50, 60, 70, they're difficult to handle all at once. All right, and making counting error can, make everything go wrong. So if anything is wrong at this stage, we cannot proceed further with our calculation. Let's say if any of the frequencies I calculated is wrong, sometimes it happens that I counted the frequency for this class as 1, and for this class I counted as 7. Eventually the total was 20, but for the particular class the frequency you counted was wrong, right? And if it happens, because since 35 to 36 there are only two set of observations are given, and I've counted only one, and 39 to 42 the observations were given in this range was 6, and I counted them as 7. So I made a mistake on my own, which will cost me, because eventually the total will be same, but within class frequency it was wrong. And if I proceed with further calculations using these frequencies, my parameters, any parameter that I will calculate with will eventually give me error. So you have to be very focused while you are doing these counting process. I hope that you have now understand that how we organize data into group form. That is, we decide the number of classes, we decide the height of the classes, we then decide the starting point of the classes, then we look at the data, that if it was discrete or not, then we look at how much gap should be given. For discrete data it should be 1 unit, for continuous data it should be 0.1 unit. All right, then we use telemark, or if when the upper limits, the classes are arranged, we saw that the minimum and the maximum observation is in our organized the numbers are in our organized table, so then we calculate its corresponding frequencies. I hope that by now you have understood it better, that how we calculate, or we say that how we organize a raw data into a grouped frequency distribution. Thank you.